Hi guys, my name is Jack Lund and I'm going to talk about optical wavelength and frequency. Wavelength is the spatial length of one period of a wave of light. Since light travels in the form of sinusoidal waves, the wavelength characterizes the length it takes for one complete period of a sinusoid. Since it is a spatial dimension, it is often measured in nanometers, and in physics, the wavelength of light is signified by the Greek letter lambda. Frequency, on the other hand, is a measure of the number of cycles per unit time. As light travels through a medium, the number of periods of the sinusoidal wave that pass through a point per second is the frequency of light, often measured in terahertz. In physics, frequency is commonly measured by the letter F. Optical wavelength and frequency are related by the equation F equals c over lambda. Therefore, wavelength and frequency are inversely related. The letter c in this equation is the speed of light, which is approximately 3 times 10 to the 8th meters per second in a vacuum. Light that is visible to humans is in the range of approximately 390 nanometers to 700 nanometers in optical wavelength. In terms of frequency, this corresponds to approximately 430 to 770 terahertz. Light that we see as red has a low frequency corresponding to a high wavelength, and violet light has a high frequency corresponding to a low wavelength. Finally, there is also light of a wavelength and frequency that cannot be seen by humans. Light of a wavelength between 400 nanometers and 10 nanometers is ultraviolet light, and light of an even shorter wavelength may be X-ray or gamma ray waves. On the other side of the spectrum, there are waves that are too high in wavelength for humans to see. Infrared, microwaves, and radio waves all have wavelengths too high to see. Radio waves may even have a wavelength greater than 1 meter long. This 1 meter corresponds to about 300 megahertz in air. Finally, back to the visible spectrum of light, humans perceive the differences in wavelengths and frequency through the phenomenon of colors, with red light at a low frequency, which is a high wavelength, and violet light at a high frequency, which is a low wavelength. And in between, we have the whole spectrum of